Oh, this is video I7, and I've written out the problem that I gave you yesterday already. I'll read it to you. So we have a rectangle. Inscribed in it, or no, I'm sorry, the rectangle is inscribed in a semicircle, and so we have to know what that means. Okay, the semicircle has a radius of 2. So before I even look at the question, I'll go ahead and draw that picture. So I have a semicircle. And I really should have said a semicircle including its diameter. And the radius is 2. Inscribed means that all 4 vertices of the rectangle will have to be on this object. And so we just randomly draw a rectangle in here. Okay, there are the 4 vertices on that object. And we don't know anything about this now. Okay, we have to find the biggest possible rectangle that we can. Okay, and I've seen students come up with some pretty clever methods for solving this, but the one I like the best is this one. I like to slap onto here a coordinate plane with the origin right at the center of that circle. And the reason I like to do that is because I know the equation of that circle. You guys know that x squared plus y squared equals 4 is the equation of a circle centered at the origin with a radius of 2. And with that, we can solve for y for this semicircle up above the x-axis. Y is the square root of 4 minus x squared. Okay, realize that if I had the negative here, that would give me the bottom of that circle. Okay. With that in mind, now I can try to find the area of that rectangle. Okay, so I have to choose some random value for this length right here. So I'll call that x. If this length right here is x, making the base of the rectangle 2x, okay, if I have that, then I can find this ordered pair. Okay, so clearly the x coordinate is the x that we've chosen there, and since this point is on the semicircle, its y value is right there. And then what this gives me is the equation of the area of that rectangle. And that's what I'm looking for. I want to find that area. I want to find the largest area. So the area relative to x as a function of x, the x that we've chosen there, is the base times the height. So 2x times that height, which is this y value right there, right there. Now, we could go ahead and try to use the product rule. I think it leads to a more difficult solution. And this is kind of fun. So doesn't this equal this? And now since I have the same index, I can distribute and maybe get a simpler version of the area formula in terms of x. Okay, so this is what we want to try to maximize. So I'm going to find its derivative and set the derivative to 0. Okay, and so this is going to be a big chain. As a power function, this to the 1/2 power, so I have 1/2 times this something right here. And then I subtract 1 from the exponent. And then since that something wasn't just x, I multiply by the chain. The chain would be 32x minus 4. Okay, so I want to clean this up and then set it equal to 0. So the derivative of the area function is, now I have a 2 on the bottom. I'm going to divide both of these by 2. So up top I get 16x minus 2. And then on the bottom I have the square root of 16x squared minus 4x to the 4th. And I just did something horribly wrong. That's not right at all. The chain appeared. I missed the fact that there was a 4 there. So bring that down, I get 16. Gerald, I'm sure you saw that. 16x cubed has the chain. totally changes this top. Now, so I still divide by the 2 here. So I get 16x minus 8x cubed. All right, so this is what I want to set equal to 0. And once again, I just set the top equal to 0. So I have 16x minus 8x cubed equals 0. Let's go ahead and factor this now. Actually, let's divide by the 8 first. So I have 2x minus x cubed equals 0. Factor out the x. I'm going to go way up top with this now. Hope you can see the bottom of that. Set each factor to 0. So maybe x is 0. Think about that. Wouldn't that give me the smallest area possible? My rectangle would be right there. Okay, so that clearly is not going to be our answer. Then this one, 2 minus x squared could equal 0, so negative x squared equals negative 2. So x is positive or negative square root of 2. Okay, you could once again make a sign chart, but the square root of 2, about 1.4, would be the x that we're looking for. Okay, but that's not what they're asking. They're asking what's the area, and so we need to substitute the square root of 2 in for x. So the area when x is the square root of 2 is 2 times the square root of 2. And then here I have 4 minus the square root of 2. I'll write this out. 4 minus the square root of 2 squared, which is 2. So I have 2 square root of 2 times the square root of 2, which is 2 times 2, or 4, the maximum area. Okay, so what I would like for you to try to do now, I'm going to give you what I consider to be days worth of work. I think these problems are time-consuming and difficult. On the review, I want you to try problems. Let me see, this was section 4.6. So 11 through 16 and 42. Okay, in the book, I want you to try page 268, 10A, and 47. Okay, so I'll post on the calendar how many days worth of work this is, and realize that you can go to page 268 or 267, wherever these start, and do as many of these problems as you'd like. I've posted all of the worked out solutions, the book version of them, on the BC portion of my website. If you have a hard time finding that, just email me and I'll show you where it is. Good luck with it all.